Alright, so everybody's supposed to be ready for notes on 5-3. And I have put back up this mnemonic that you already have in your 5-3 notes so we can refer to it. You do not need to copy this mnemonic down unless you just want to have it a little closer to where you're working your questions. So when you draw all sine, tan, code, that's a mnemonic to help you remember that when you go counterclockwise from quadrant 1, who's positive? Everybody's positive in quadrant 1. But in this quadrant, only sine is. In that mnemonic, all sine, tan, cos. So that meant cosecant had to be also, since you flip sine to make cosecant. And everybody's positive down here for tangent because y and x are both negative and the negative cancels out. So that makes cotangent and tangent both positive. But everybody else is negative. And then down here in quadrant 4, you're looking at only cosine is because x is negative and y is positive. So therefore cosine and secant are both positive. I said that right, I think. That cosine is positive and y happens to be negative down here. So that makes cosine the only one that's positive because if y is negative, so would tangent be negative. So this helps you to remember who's positive. To be positive, you have to be bigger than 0, right? Okay. So over here I have 3 examples of questions in which we're going to use the mnemonic over here to determine if my angles are greater or less than 0, what quadrant would it fall in? And the object about this is to figure out if sine is less than or greater than 0, for example, then you want to compare it to another angle and see if there's something they have in common. So I've done it with sine, cosine, tangent, cotangent, secant. You can do this with any of your functions. So for this to say sine is greater than 0, that means I want it to be positive. Would everybody agree with that? On this mnemonic over here, where does it say sine is positive? What quadrants? It says it on quadrant 2. Well, what other quadrant? Quadrant 1 also, because it says everybody is there. All right, over here, for cosine to be less than 0, that means it has to be negative. So that means I'm looking on this mnemonic for where cosine is not listed because it's negative where I didn't list it. Where did I not list cosine? Well, everybody's listed right here. I just didn't write all the words out. So that would be 2 and 3. Because cosine is positive here, everybody is positive here. So since cosine is positive in both of these quadrants because x is positive in both of these quadrants, right? Then cosine has to be negative where it's not listed. So if you need to see all the words, write all 6 words in this box if that helps. So that would be 2 and 3. So the object behind this is see which quadrant do they have in common. 2. And that'd be where I'd be drawing my picture. Yeah. Number 2. So this time we're looking for sine is less than 0. What does it mean to be less than 0? Negative. All right. So where on this mnemonic is correct? See, everybody's positive here. Sine is positive here, and I'm looking for negative. So I'm looking for where would the word sine not be listed. Sine is not listed here or here. So that is in quadrant 3 and quadrant 4 because I don't have the word sine there. And granted, I guess it doesn't look like I have the word sine up here, but it says all, which means all of them are positive there. All right, tangent is less than 0. All right, so we're looking for negative. She says quadrant 4 because there's no tangent word right here. Where else is there no tangent word? 2. Because it's positive here. Why is it positive here? It's because there are 2 negatives, right? X and y are both negative in this quadrant. They cancel out to make y over x. And up here, everybody's positive, so it can't be negative there. So what do they have in common? 4. This will help you to be able to be given some information and know how to plot it on your picture. So secant is less than 0 is my last one down here, with cotangent is greater than 0. So secant being less means negative. So 2 and 3, because wherever cosine's positive, so is secant, right? So they have to be negative over here at 2 and 3. And then cotangent's greater than 0 means go find where you wrote cotangent, because it's positive. 1, everybody's positive, and 3, you're correct. You see the word cotangent there. So what do they have in common? 3. All right, so now let's look at whatever information I give you, you should be able to figure out where to put it. So, what if I gave you 2 of the 6 trig functions, and I asked, it says find the exact values for all 6 trig functions. Well, I already got 2 of them, right? Everybody agree with that? Okay. So I just need to list the other words and see if I can figure them out. So I have secant and cosecant, well, cosecant and secant and cotangent. All right, so I've listed the other words, but on this lesson, I think we're going to try not always draw the picture for every question, because if you have X, Y, and R in the first 2, you don't need to draw a picture to figure out what X, Y, and R are, right? Because this is Y over R, and this is X over R. So I think it wouldn't be too hard to make tangent. It's just the top of those 2 fractions, right? So that's negative 3 over 4. And then we just flip them all. Negative 5 over 3, 5 over 4, negative 4 over 3. So because I gave you 2 functions, that wasn't very difficult, was it? Would it matter which 2 functions I gave you? So no matter what functions I gave you, you feel like you would be fairly confident that you could pick out the X, Y's, and R's. And
Well, if you gave us tangent, wait a minute, if you gave us cotangent, which is Y over R, wait a minute, I gave us cotangent.
okay. So see, in this, I'm not going to do this problem, so don't write it down. But this is the same thought we just did, right? I gave you 2 things that are really obviously X, Y, and R. So you're right. It could be a little bit more difficult if I did not give you X, Y, and R.
Well, if you just gave us X and Y, then we can find the R easily with the Pythagorean theorem.
Exactly.
Like an X and a Y and an R, I guess we'd be able to find it.
Did we skip 2 on purpose?
I did skip 2 on purpose because it's just like the first one. I'm trying to shorten this a little bit. All right. So in this problem, I have Y over X, and I've been told it's a quadrant 2 angle. Now, I could draw the picture, and that might be very helpful sometimes, because in quadrant 2, who's negative? X. X is negative, Y is positive. But is that what my fraction up here is telling me? Because what did somebody do with that negative? No. They moved it to the top because that's where it's supposed to be. So drawing a picture can be helpful to see that your Y is not negative in quadrant 2. So X is 5, it's going to be negative, 12 here, because in quadrant 2, the X's are negative and the Y's are positive. So then I did Pythagorean theorem. I'm going to focus on this just for a moment, even though she's already told the answer, because I keep seeing people miss this. Don't put any negatives in there. Yeah, don't put the negatives in here because you're not doing it right. Your calculator is not doing it right, and you are not writing it so your calculator can do it right. So just don't put any. It don't need it. If you square something, it's going to be positive, so just don't even put them. So that's 25 plus 144 is 169. And what's the square root of 169? 13. Oh, that's that number I told you to memorize. 5, 12, 13?
Yeah.
Yeah. So now we have the sine of theta, the cosine of theta, and tangent of theta on this side they gave us. So we just got to go back and take that R value and put it back under each one of these, right? But we need to do it from the picture because the negative's on the wrong one. So that's why these are both going to have 13 on the bottom. And our picture says that y's in quadrant 2 are positive, so that's going to be 12 thirteenths. And our picture says that x is going to be negative 5, so that's going to be negative 5 thirteenths. And what are you going to do to make the other three? All right, you write the next three, flip them, write them down. Well, I see which question I want to go on to. I'll freeze it so I don't mess you up. Okay. All right. Okay. So that wasn't difficult, was it? But the picture did help you to figure out who was the real negative, right? I could have done it without the picture also, because I could have just said what I wrote over here. Let me make my x negative, not my y. Does that make sense? The picture just helps a little bit more with visual. What? Okay. All right, number 4. In question number 4, they told us which 2 degrees it has to fall between. And it gave us one answer only. I don't know. Did I not leave it long enough? You looked at it and said, okay, and I assumed you was done. This one? Okay, yeah, that's enough. He said okay, so I thought that meant he's good. Let me move on. Instead of he meant I'm okay, I'm at the right problem now. All right, ready, Junior? Okay. All right. So in this one, they've given me cosecant, which I could flip back, right? And if I flip it back, it'd be negative 9 over 41. Would everybody agree with that? Okay. Now, that doesn't tell me a huge amount, but it just tells me 2 of them. Everybody agree with that? Yeah, I just didn't draw the little line in the middle. All right. But what quadrant does 180 to 270 fall in? 3. In quadrant 3, who's negative? Everybody. What do you mean by everybody? X and Y. Not R, right? R is never negative. Which is why when we flip it, that negative made sense on the top, right? Okay, then cosine, what we know so far is the top needs to be negative and it needs to be over 41, but we don't know the top yet, right? We'll get that in a minute. Would everyone agree? Okay, and then tangent, is tangent positive or negative in that quadrant? Oh, it's always positive in quadrant 3. So that makes sense on why these 2 negatives are going to cancel out, right? All right. And then, of course, if we just had that one more number, we could fill out the rest of our chart. Well, 9 squared plus b squared equals 41 squared. This is one of those Pythagorean triples, so that's 1681 minus 81. Yeah, I know that one. 1681 minus 81 is 1600. The square root of 1600 is 40. 9, 40, 41. So that makes 9 and 40 my tangent. Would everybody agree with that? And then I just flip them. So the main focus of this lesson is the same thing you did before, but you just got to do a little work to fill in enough numbers to know your X, your Y, and your R. And what quadrant it is in helps you to fill in the signs because you may not have all your negatives or positives that you need to know from just looking at the problem, like number 1. All right, last thing. What if they give me one value, but they tell me something like we had in those first 3 questions about it being less or greater than 0? All right, so when we look at our 6 trig functions, I'm just going to write them all out real quick. The only one I know right now is secant. Would everybody agree with that? Well, if we know secant, who else do we know? Cosine, because cosine's 1/2. All right, now let's focus on the cosine of 1/2 and this sign up here being less than 0 for a minute. Okay? Cosine being 1/2 means it's positive. What quadrants is cosine positive? 1 and 4. All right. Sine less than 0. Well, where's sine negative?
3 and 4.
Everybody agree with that? So what quadrant am I in?
4.
If I'm in quadrant 4, and the cosine is positive, and the sine is negative, then that means x is positive and y is negative. Would everybody agree with that? So now I know that I have a 2 on the bottom here, right, because the radius. I know that the top number is going to be negative because of what quadrant it fell in, and that I can use a squared plus 1 squared equals 2 squared to get it. 4 minus 1 is 3. So it's square root of 3. Oh, that looks familiar.
Oh, look at that.
That's one of our unit circle numbers, right? So this one's negative square root of 3, because if you put it over 1, you can just throw the 1 away, right? And then if you flip this one, isn't that going to be negative 2 square root of 3 over 3 once you rationalize it? Because after a while, you just kind of know that one. And if I flip this one, it's going to be negative square root of 3 over 3 if I rationalize it. You use those values so often, you may end up not having to rationalize them and just know what they are. All right, so we've got 15 minutes, which is plenty of time for our unit circle quiz.